Good day to you. This is Galactic bringing you another science presentation on Wednesday. What I'd like to introduce today is a very simple concept. Now, what we want is the inverse of the unit circle, but before I show you that, I just want to show you these two lines, which I've never heard anybody talk about the way I'm about to talk about them. You know that that is 2D, and if you know something about either the history of mathematics or you work with it closely enough that you happen to know that this grid is called a Cartesian plane. A plane is a 2D surface, and you've heard of 3D. 3D is when you have depth. Show me that line here. Where is the third line? Well, I think you can guess. First of all, it has to be centered on 0 because all lines are centered on 0. These two lines are centered on 0, and so the third one is orthogonal to both of them. And so you can't see it. And so it's invisible. It's imaginary. And, of course, it's infinite. So it's invisible, imaginary, and infinite. All three lines are infinite the way they're drawn. Nothing in the universe is infinite, so that's a mistake. The 0 is a mistake, that's an infinity. And so we have no representation of reality at all. That's not true. That's not true. And what was left out of most people's education in the basics of thinking, rational logic, just how to use your noodles, so that you're logical and truthful and you can get results. Well, the notion of grid space is something we were forced to learn. None of us signed up for it. And so what does it purport to be? Well, the first thing I'd like you to notice is that there is a center to the linear systematic space. The linear systematic space is comprised of 5 standard objects called dimensions, and each dimension is an object. There's 0, 1, 2, 3, and 4. 4 is for space-time. That was extended to imaginary space by Albert Einstein. But Albert Einstein did not invent imaginary space. You're looking at it. The Cartesian grid is a squaring of the linear surface, which we call a plane. All it is a line that has been rotated all the way around until it's closed. And you will notice that that would be circular space, and that matches physics. This does not match physics. This is a squared surface. That's why we have so many squared numbers. Now I want you to think deeply right now about something that I'm bringing up here. When you try to correlate squared space with physics, which is spherical, and therefore if you reduce the sphere, it's circular on the plane. Everything is in a curve on a closed line. Why do we use 3 open lines? Do you know? Now look at this grid and you'll notice that the 2 lines are at right angle. Is there some principle in the universe that dictates that that has to exist? Or did we just make it up? This is highly pertinent now in the quantum theoretical arena because everyone is looking for some madcap angle on the paradox. Now I wish to replace the word madcap with a more rational term. What we're looking for in the quantum paradox situation is a means of perceiving what we cannot yet perceive. And on this point, you have to take a philosophical notion of faith. This would be the Einsteinian principle or the Emersonian principle, it has been called. It has other highfalutin names in philosophy. But it's the basic ruling scientific principle that if you have a rational question that you wish to ask the universe will answer it with a rational answer. You do have to follow the rules. There is always that footnote so easily overlooked. There are rules to this game. What we're after is a direct perception of universal dynamics that will explain light, which is electromagnetism, and will explain the quantum completely, and will give us the necessary insight such that we may use mathematics to compute macrospace objects, which now extend beyond the radius of the moon. We know about the planets we have for a long time. We just discovered the galaxies a century ago, and a little less than a century ago, we discovered the third cosmic unit. One of my teachers discovered the clusters of galaxies. You would have to ask, are there any higher order structures? If there were, the next one in our progression would be the next largest luminous object composed of smaller luminous objects. So we have the star, cosmic unit 1, the galaxy, all stars are in galaxies. The third cosmic unit is called the cumula. I wrote a book called The Realm of the Cumula. The realm of the cumuli, plural, actually, to match Hubble's book, The Realm of the Nebulae, which was his word for galaxies. And as far as I know, he never switched. And he was the last man on the face of this green earth to use the word nebulae for galaxies. You might be interested in researching who was the first person to use the word galaxy of what had been called a nebula. There is a fourth cosmic unit, which was discovered approximately in the 1960s, but it took another 50 years to have enough resolution from our ever more powerful telescopes to decide what it is we were seeing, into which cumuli are just objects in a larger object. At first they were called superclusters because the galaxy clusters were called exactly that, galaxy clusters. I gave it a more meteorological name, cumuli, to start a trend of renaming in a more congenial fashion to humans, such as myself. And the next level would be the superclusters, the fourth cosmic unit. There's star, galaxy, cumuli, and then the fourth one, supercluster. And the transition in knowledge that occurred into the 21st century, but it was more or less finalized right at the end of the 20th century after about 40 years of research, mostly by de Vaucouleurs and his amazing wife in France. Immortal name in astrophysics is de Vaucouleurs, Gerard de Vaucouleurs. And he discovered what then, and he was exploring further than most astrophysicists, but he understood that these were superclusters, which would simply be another larger sphere. But in this case, what was discovered really right about when de Vaucouleurs died, within a decade, it was ascertained that what had been thought to be superclusters were actually a hybrid object which I can now tell you are vertices of polyhedra. Vertices of polyhedra means the place where a solid shape in space, the simplest of which is the tetrahedron, then the cube, and then there are the 5 Platonic solids, which really occupied the mind of Kepler, and certainly not Kepler alone. Certainly going back before Kepler, the 5 Platonic solids had something of a superstition attached to them, which has never completely gone away. But in any event, polyhedra can be, those are regular polyhedra, but polyhedra are just volume objects that have facets for surfaces. They're linear objects, which forms the counterpoint to my rather one-sided insistence that the linear systematic space consisting of the 5 known dimensions is something equivalent to crap. Well, the universe contradicts me. And so I have to, every scientist should be cautious, but we all, at the cutting edge, you really have to throw caution to the wind for a while. But it can become habit forming. You just learn to exaggerate and just challenge anything, and because you're thinking outside of the box. Now this that you're looking at on this screen over here is the box, and we need to start thinking outside of it. But it's not crap. There are 3 linear dimensions. It's just that the third one is imaginary. It actually is the 5th definition of imaginary that I've found that corresponds to either physics or mathematics or both. Because you can't see that third line. If I were to switch to 3D, you now can see the depth, but you see it has to be at an angle. Because if I rotate this way, we're back to where we were. So that's 2D, and that's 3D. But what you're looking at the entire time is 2D. You're looking at a 2D surface physically. But represented in your brain now is the third dimension. Why? Can you state accurately why that gives you the impression of 3D? Now you see the other axis disappeared again. Let's do that again. There's the third axis, but if you rotate this to exactly the right position of orthogonality, that entire line collapses to a point. It collapses to a point. And so in this very brief video lecture, I'm now going to give you again, but from a different perspective, the collapse of the wave function. Look at this, and you see the vertical axis, Z in blue, and now watch carefully as I rotate this. It's getting shorter and shorter. The other 2 lines are changing perspective, but not at the same rate. And this one goes to 0 precisely when the other 2 become orthogonal again. So it's a symmetry. That 3-ness has baffled the minds of mathematicians for centuries. But I'm going to give you the physical insight into what is actually happening that can be proved mathematically. But this is a geometric demonstration of how this straight line, which is not a wave, it's a straight line, it collapses to non-existence. Well, of course, we know it's there. What is the word we use for something that when we look at it, it is non-existent? But then when we use geometry and mathematics, we can prove that it exists. With geometry and mathematics, we can make this non-existent point become real. And if we go far enough, the other part disappears. This is the disappearance of the plane. This is the disappearance of the line. Where are those objects going to? They're going to invisible space that can be extended. They're going to imaginary space. Right? Is imaginary space real or not? Obviously it's real. Then why do we call it imaginary? It's because we cannot see it. Here, when you do this, your mathematical system cannot see it. Your number system is blind to the third dimension of space. Your number system is blind to it, but only at certain aspects. Here, the third dimension merges with one of the two other dimensions. That's called gimbal lock. Gimbal lock. And it almost killed 2 of our astronauts while they were landing on the moon. You don't hear about that very much, do you? Your linear mathematical system is a killer. It has a 0 in it, and that number is imaginary in real space. That is called a black hole. Do you know why it's called that? I'll tell you. It is because it's the point center of gravity. The point center of gravity cannot exist. It's imaginary. Okay, so now you've seen the imaginarity in at least 3 ways: geometrically, visually, mathematically, and now you're going to see it for real. Because that space that we cannot see, it's not just our machinery, it's not just our numbers or our arithmetic or our mathematical tools. It has something to do with reality. And reality, OMG, is that the hot topic now? This is how you come to grips with the imaginarity of reality. No matter where you look, how you look, when you look, or how fast you look, there is a dimension to space that is so real that it gives you vision. And I could make a list of magnificent attributes that all comes from orthogonality. Orthogonality. This magic relationship between 2 straight lines, which if you add the third, it's imaginary and invisible. Invisible is a hierarchically, imaginary is higher ranked. Invisible means it's imaginary with respect to your vision. And that is, invisible means it's imaginary with respect to your vision. But imaginary goes far beyond vision. It's something that can't be computed. It can't be represented with a number system. It can't be imagined. And so we play with our numbers, which are inherently incapable of seeing the dimension that you want. You're looking at the proof of what I just said. Where is the third dimension? Right? It's here, right? But if you rotate it, you can't see it. That is also true in spherical space, and what we see as distance is about 1/6 of the reality. That is 1/6. You might ask, how am I so confident of my numerics? How am I so confident of my computation of the two versions of space? It's because the relationship between the sphere and its radius, first of all, can be reduced to a circle, because the circle and the sphere are directly related on a dimensionless quantity, a constant. But you can find that number much more easily by computing it from the circle, which is simply a linearized sphere. But it's still closed. It's not an open line. It's a closed line. So what we have here is a circle that is bisected into orthogonal directions. A few things that I would like you to notice about the circle with respect to the Cartesian grid is that the circle is never at any time on the grid. The only points that can be computed in the Cartesian plane are square points, and those have a double zero. It's actually a quadruple zero, as I'll be showing you shortly. But a curved line is never at any point on the Cartesian plane. The circle is in a different dimension, and it passes between the points of a Cartesian plane. The circle is entirely imaginary. The elements of sacred geometry are not as we were shown in the various books produced by that name, Sacred Geometry, of which I own 2, but I know of at least 24. These books of so-called sacred geometry are due to an intuition that there is sacredness in geometry, but alas, for 2,500 years, mankind has been searching for that sacredness in the Cartesian plane. You can go all the way back to Euclid. Nothing has ever changed. Those crosshairs that are at orthogonal angles, those are non-existent points. That's what Euclid said. Every point is non-existent. So the entire fantasy of Euclidean geometry is bound to the fact that we have two modes of perception, and the universe has two ways of presenting herself to us. For our convenience, and for that reason alone, nature designed that mankind would learn about the Cartesian plane. This is named after René Descartes, who's a meaningless character in the ultimate sum of things, but he made some interesting observations that simply caught the attention of ape-like humanity. Now, the grid is a scaffolding. Space is spherical, and it has a circular characteristic called the eigen of the sphere, which is angular momentum. Angular momentum is a two-component quantity, just like light speed. And so we're justified in saying that this circle represents light speed. On the surface of the circle is a unit value called spherical 1 proportion 1, that is space and energy. That is the new Einsteinian equation. But alas, Einstein never noticed it. I noticed it. And so this could be called Milsteinian geometry. And for those of you, my friends, who are soon to die, along with your relatives, I suggest you take notice of what you're seeing. Because you're not going to teach me about music or dancing or politics or religion. I will be teaching humanity from now on. That's the way it is. So you're looking at light speed, you're looking at the quantum of gravity, you're looking at the collapse of the wave function, a new geometry, a new mathematics, a new arithmetic, an entirely new educational system. So thank you very much for tuning in. Keep